A very good evening to all of you. This is Shivam Shukla, and here I am to solve a problem on resultant of general force system. The problem is based on the location of resultant with respect to origin. It's a university problem for 6 marks. Let us see how the question statement goes as. Determine resultant of force system from point O. That means what are we supposed to find? As you can see the questions diagram, we are supposed to find the resultant R of the force system, and even we are supposed to find out the direction of the resultant, that is theta. Even with respect to this origin O, where does this resultant passes? Okay, so let us go one by one with the steps. Now, as we can see, there are total 5 forces acting in the system. 3.5 kilonewton towards right, 8.5 kilonewton acting at a particular angle, 7 kilonewton acting at a particular angle, and 5 kilonewton acting at a particular angle, and 12 kilonewton acting vertically downwards. Now step 1, we will be drawing the free body diagram. For drawing the free body diagram, whatever the forces are at some inclination, they are needed to be resolved. As you can see, this 3.5 kilonewton and this 12 kilonewton, they won't be resolved. Let us be very specific. Wherever we will be resolving the forces, that point we should be keeping very specific, because that will be useful when we calculate the moment of the forces. That is when we apply the Varignon's theorem. Let us go one by one. Let's see the free body diagram of the problem. Okay. So as you can see it over here, here is the 3.5 kilonewton force, this one. 8.5 cos 45, basically we have resolved it over here. 8.5 sin 45. Now, before going to this resolutions, let us first find out the angles. Various angles are there. How did we get those? Now, for example, this theta 3 is there. How did we get this as 45 degrees? Example, here we will be considering one particular square of it, where I can see this will be a right angled triangle. So opposite side is 200 to 400, that is 200. The adjacent side as well, it is 200 to 400, that is 200 mm. If I calculate the theta over here, so by using tan formula, that is tan of theta is equal to opposite upon adjacent. Both the sides are equal. That is why it will be theta is equal to theta 3 is 45 degrees. Again, if I consider this particular angle, that is theta 2, let me say this one. Okay, so this is a right angled triangle over here, my dear friends. So now tan of theta 2 is opposite, totally opposite, that is 400 upon adjacent. Adjacent is also 400, that is why theta 2 will also be 45 degrees. So 90 minus 45 will be 45, that is why angle with respect to x-axis is 45 degrees. Going ahead, if I consider this particular rectangle over here for theta 1 for 5 kilonewton force, this right angled triangle theta 1, opposite side is of 200 mm, adjacent side is of 400 mm. So tan of theta 1 is equal to 200 divided by 400. That is why theta 1 is equal to tan inverse of 200 divided by 400, which will be giving us as theta 1 is equal to 26.565 degrees. Now these were the angles. As you have seen, the resolution of the forces are done. 8.5 cos 45, vertical will be 8.5 sin 45, 7 cos 45 over here, 7 sin 45 over here, 5 cos of 26.565 over here, 5 sin of 26.565 over here. Okay. As you can see, this is a general force system of 5 forces acting on the particular plane. This was the step number 1. Let us go for step number 2. Algebraic sum of all the forces acting towards right as positive. This is the formulation of it, summation of fx. Now let us see how it has come. So if I write summation f of x, how it is going to come as, let's just go to the FBD and try to get the equation. Okay, so this is plus 3.5 plus 8.5 cos 45 plus 7 cos 45 plus 5 cos of 26.565. So everything is going to be plus, because all are acting towards positive x-axis. So as we have seen it over there, this is the equation, and the value that we got it as 18.932 kilonewton towards right. Summation Fy acting in upward sense is positive. That will be that will be again, if I see, it will be minus 8.5 sine 45 over here, minus 12, minus 7 sine 45, last but not the least plus 5 sine of 26.565. That is 5 sine of plus 5 sine of 26.565. Let us just check the equation. So minus 7 sine 45 plus 5 sine of 26.565 plus 8.5 sine 45 plus 12, sorry, minus 12 it is. So the value that we got it over here, my dear friends, it comes out to be in minus. That is why it is written as 20.729 kilonewton acting vertically downwards. Now, magnitude of the resultant R is nothing but square root of summation of fx the whole square plus summation of fy the whole square. So R is equal to 28.069 kilonewton acting towards fourth quadrant. Why is it so? Because summation of fx is acting towards right, summation of fy is acting vertically downward, and R is acting between those. So that is why it will be acting in a direction of fourth quadrant. Theta is equal to tan inverse of modulus of summation fy by summation fx. So theta is equal to tan inverse of this. So theta's value is 47.587 degrees. Now, location of the resultant. Let the resultant be located at a perpendicular distance d to the right hand side of O. By Varignon's theorem, the formula goes as like this. Let us go to the questions diagram and let us frame the equation by seeing over here, over there, and then we can verify the equation by coming to the problem back. So I am over here. Algebraic sum of moment of forces about O is equal to moment of resultant about the same point. We have considered the resultant will be passing to the right of O. So that is why it will be acting towards fourth quadrant like this. Okay, one by one, let us go with the forces. So here it is 8.5 cos 45. This particular force I am considering it over here on this point. See, it's a tactic, my dear friends, by the principle of transmissibility of force. You could have considered it over here, you could have considered it over here, or even you could have considered it over here. So friends, you should not get confused. You can take it straight away. It's quite easy. Better, wherever I will be resolving the force, on that point only I will be taking both the components. It is not like cos component will be taken here and sine component will be taken here, because that totally changes the meaning. That is why, just try to understand very carefully. I have considered 8.5 cos 45 over here, 8.5 sine 45 over here. Now, starting with it, 8.5 cos 45, since it acts towards right, if I keep my right hand thumb at point O and with the help of the first finger I try to rotate the 8.5 cos 45 force, it will be definitely rotating the body in clockwise sense. That is why in equation it will be going as 8.5 cos 45 into 400. I hope it is understandable for everyone. Second point, 8.5 sine 45, since it acts vertically downwards like this, so the perpendicular distance is 200 over here. Again, it will be causing the body to rotate in clockwise sense. That is why 8.5 sine 45 into 200, that is plus 8.5 sine 45 into 200. Next, what about this 12 kilonewton force? Definitely, since it acts vertically downward, same way there is a basic concept. You can keep your thumb pivoted at point O with the help of the finger. Definitely, I'm talking about right hand. You can try to rotate with the direction of 12 kilonewton force. Definitely it will be causing the body to rotate in clockwise sense. That is why it will be plus 12 into 600. This is the perpendicular distance. Going ahead, same way, plus 7 cos 45 into 400 plus 7 sin 45 into 800. Now plus 5 cos of 26.565 into 600. Now 5 sin 26.565. If I apply the same rule, that is, I keep my thumb pivoted at point O and with the help of the right hand finger I try to rotate it in the direction of 5 sin 26.565. Definitely it will be causing the body to rotate in anti-clockwise sense. That is why it will be minus 5 sin 26.565 into this perpendicular distance is 800. Last but not the least, it's the 3.5 kilonewton force which is there at the top. This one, that will be plus 3.5 kilonewton, the plus 3.5 into 1000 is equal to whatever is the resultant value into d, because resultant is acting towards fourth quadrant, that will be also in clockwise sense. So you can see this entire equation explained very clearly by me by looking at the diagram, and resultant value is taken as positive into d. Since the value of d comes out to be positive, that means our assumption of the resultant force to the right of O was correct. Therefore, R is equal to 28.069 Newton, 28.069 kilonewton at theta 47.587 degrees towards fourth quadrant, acting at a perpendicular distance d is equal to 753.17 mm to the right hand side of O. So friends, please do like, subscribe and share this video. Thank you.